Today we're on pages 206 and 207 of our textbook. You need a calculator. Lesson 11, solving quadratic equations with complex solutions. So as we saw in previous lessons, the roots or zeros of any quadratic equation can be found using the quadratic formula. Since the formula contains our square root, it's fair to investigate solutions to quadratic equations now when the quantity b squared minus 4ac, known as the discriminant, so what's underneath the square root, is negative. Up to this point, we concluded that if the discriminant was negative, the quadratic had no real solutions. But now we have complex solutions. So basically all we're doing is we're solving our quadratic equations, and if we end up with a negative underneath the square root, we will continue to simplify it. Use the quadratic formula to find all solutions to the following equations. Express your answers in simplest a plus bi form. So that's a hint right there telling us that, oh, we're going to end up with a negative underneath the square root symbol. Okay, so x squared minus 4x plus 29 equals 0. A is 1, b is negative 4, and c is 29. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. So negative 4, making our substitutions. So x equals 4 plus or minus the square root of, this is 16 minus 116 is going to be negative 100. Now let's split, right? So this is 4 divided by 2 plus or minus the square root of negative 100 is 10i divided by 2. So this is 2. 2 plus or minus 5i. So as long as our solutions can include complex numbers, then any quadratic equation can be solved for two roots. Solve each of the following. Express your answers in a plus bi form. Standard form first, so let's subtract 7x and add 10. I'm going to use complete the square for this one. All right, it's good practice. X squared minus 12x plus blank equals negative 40 plus blank. What goes in the blank? Negative 6 squared is 36. X minus 6 squared equals negative 4. Square root each side. X minus 6 equals plus or minus 2i. Add 6. X equals 6 plus or minus 2i. B, standard form first, subtract 10x and subtract 4. X squared plus 6x, subtract 4 plus 11 equals 0. I'm going to do the same. I'm going to use complete the square. Again, you can use complete the square as long as your leading coefficient is 1, and it's easier if the coefficient of your linear term is even, which this is. So x squared plus 6x plus blank equals negative 11 plus blank. 6 divided by 2 is 3. 3 squared is 9. This factors into x plus 3 squared equals negative 2. And square root each side. x plus 3 equals plus or minus I square root of 2. X equals negative 3 plus or minus I square root of 2. And if I have a preference, I prefer to use complete the square over quadratic formula. I just find it easier to work with. But you're certainly more than welcome to have used quadratic formula on both A and B. Okay, now the connection between x-intercept zeros of a parabola and complex roots with non-zero imaginary parts. Consider the parabola whose equation is y equals x squared minus 6x plus 13. Algebraically find the x-intercepts. Excuse me. Express your answers in simplest a plus bi form. Okay, that's telling us right there we're going to end up with a negative underneath our square root symbol. Okay, so 0, replace our output y with 0. 0 equals x squared minus 6x plus 13. Again, I'm going to use complete the square. And I'm just going to write it with these terms on the left side and 0 on the right. So x squared minus 6x plus blank equals negative 13 plus blank. Divided by 2, negative 3 squared is 9. So we have x minus 3 squared is equal to negative 4 square root. Both sides. X minus 3 equals plus or minus 2i. Add 3 to both sides. So x equals 3 plus or minus 2i. So these are the x-intercepts. Wait, how could we see them when our x-axis, these are real numbers, right? So let's see, 3 plus or minus 2i. Using a calculator, sketch a graph of the parabola on the axis below. Use the window indicated. All right, so we key in x squared minus 6x plus 13 into y equals. There it is. And let's adjust the window. X's are going from negative 5 to 10. And y's from negative 5 to 20. And press graph. And there we have it. It doesn't even cross the x-axis. So I know the y-intercept there is a 13. That's 13. Again, this is just a sketch, something like this. From your answers to A and B, what can be said about the parabolas whose zeros are complex roots with non-zero imaginary parts? These parabolas do not cross the x-axis. Or intersect the x-axis. Use the discriminant. Now remember, the discriminant is the b squared minus 4ac part of the quadratic formula, the piece that's underneath the square root symbol. Use the discriminant of each of the following quadratics to determine whether it has x-intercepts. So it will have x-intercept if b squared minus 4ac is, I'd say, greater than or equal to 0. As long as that piece is not negative, then it will have x-intercepts. Okay, so we only want the b squared minus 4ac part, so b is negative 3, a is 1, and c is negative 10. Okay, so negative 3 squared minus 4 times 1 times negative 10, that's 9 plus 40. It's So that's 49. So this would have, yes, has x-intercepts. A is 1, B is 6, C is 10. B squared minus 4AC. 6 squared minus 4 times 1 times 10. That's 36 minus 40 is negative 4. Does not have x-intercepts. And C, A is 2, B is 3, C is 5. 3 squared minus 4 times 2 times 5. That's 9 minus 40, which is negative 31. So this would does not have x-intercepts. And lastly, which of the following quadratic functions, one graph, would not cross the x-axis? Well, the one who's the discriminant. Discriminant is negative. Alright, I guess you have to go through all of these. B squared, it's going to be 5 squared, minus 4 times 2 times negative 3. That right there, that's going to make that a plus. So this is going to be positive. Negative 1 squared minus 4 times negative 1 times 6. This also is going to be a positive because that's the double negative there makes it a plus. Negative 4 squared minus 4 times 4 times 5. This is the one, right? This is going to be 16 minus 20 times 4 is 80. Yeah, this one is negative. So choice 3. And that concludes today's lesson. Thank you for your attention.